go ahead and turn in your book to the next section. Just turn the page. But now I'm frozen. Okay, and we kind of got an introduction to today's stuff yesterday. I kind of pushed us ahead. Can I scroll yet? There we go. Okay, lesson 2. It's called Representing Ratios with Diagrams. But before we get started on this, it's wanting to refresh some of our mental math here. Let's look at, I'm going to exit out of this to make it bigger. Look at this number talk here. The number talk says dividing by 4 and multiplying by 1/4. Does anybody know anything about dividing by 4 and multiplying by 1/4? Leo? No. We're not doing it in the same problem.
Oh.
Owen?
If the number is less than a whole, you're going to get like smaller number than you're like multiplying.
Okay. I agree. Okay, let's just do this math. What's 24 divided by 4, Dawson? 6. Go ahead and turn the page, Dawson. We're on the next page. Now, 1/4 times 24. Let's work it out the long way, and then we'll see if we can find the trick, because there is a trick. Tatum, how do I work this out the long way? How do I do 1/4 times 24? Yeah, so I do 1/4 times 24 over 1. Then I multiply straight across, right? So 1 times 24 is 24. 4 times 1 is 4. What's 24 divided by 4? 6. We just did that above. So on the first one, I divided by 4. On the second one, I took 1/4 times that same number. And what did we get on both of them?
6.
The same answer. Okay, let's look at the next one. 24 times 1/4, what's it going to be? Next one's weird. Does yours say 5 divided by 4 also?
Yeah.
Okay, what's 5 divided by 4? Owen? 1 and 1/4. Or could we say that it's 5/4? Yeah. Is that the same thing? Yeah. But it's not a good final answer. 1 and 1/4. What do you notice? I'm going to focus in on those two. What do you notice there? We got the same answer and they're different problems. Afton?
I don't know. Wait, yeah, they're pretty much like the same. Is this a 1? Yeah. You're doing like the same problem, pretty much the same equation.
Okay, yeah, we're getting the same answer. So I'm going to teach you the trick, and I think we talked about it last year. I want you to write this out to the side. 1/3 times 27. If I did that the long way, I would get 27 over 3. What's 27 divided by 3? 9. What do you think the trick is? And this only works if I'm multiplying a whole number by a unit fraction. What is a unit fraction? Owen?
Like one of that number.
A fraction with a numerator of 1 is a unit fraction. Anytime you're multiplying a whole number times a unit fraction, you can just take the whole number divided by the denominator. What's 27 divided by 3? 9. That always works. Always.
But
It has to be a unit fraction times a whole number. So let's do another one. 1/7 times 49. Yeah, I can just do 49 divided by 7, and I'll get 7. Now, sometimes it doesn't work out nicely. still that it's not wrong, it just doesn't work out nicely. If I have like 1/8 times 15. Is 8 a multiple of 15, or is 15 a multiple of 8? No, so that's one where we would have to divide it out to get a mixed number, but the idea still works. We could do 15, I'm just going to write it as 15 divided by 8 a different way, and then that would reduce to, yes, 1 7/8 when I divide it out. So we're going to keep throwing this rule in because it will make your life easier. Okay, if you can remember, if you have a unit fraction times the whole number, you can just take the whole number divided by the denominator to get your answer. So dividing by 4 and multiplying by 1/4 is the same thing because they're multiplying by the what? Reciprocal is all they're doing there. So dividing by 4 and multiplying by 1/4 is the same thing because that's like multiplying by the reciprocal. Okay, back to ratios. You guys need to go ahead and turn the page. Here is a collection of snap cubes. Choose 2 of the colors in the image and draw a diagram showing the number of snap cubes for these 2 colors. We're taking one picture and drawing it out as a diagram. So if you look at the bottom of this page, they kind of showed us a diagram. Usually they just use basic shapes in different sizes, okay? Or different colors or different shapes. So, Emmy, pick a color. What color? Green?
Pink.
Pink? Sorry, I can't hear. Okay, so let's write a P for pink. A P for pink. How many pink ones are there? 3. So I'm just going to do 3 squares or rectangles. Ethan, pick a color.
Green.
Green. I'm going to put a G. How many greens are there? 2. So I'm going to we'll put stars for green. 1, 2. Now, if you're drawing diagrams, you got to think back to like your sorting days where you had to sort shapes and pass them out evenly. Is there any way I could group these to where every group would have the same amount? No, so that means my ratio would just be 3 to 2. It cannot be simplified. Okay, if I can't group them at all where every group is the same, then our ratio is just what it looks like. So my ratio of pink to green would be 3 to 2. Pink to green would be 3 to 2. And again, a lot of times they will give us just this picture, but sometimes they will give us a diagram that looks something like this, and we have to pull a ratio from it. Go down to the bottom, 2.3. Blue paint and art paste. A lot of times with ratios, we can make equivalent quantities, so they refer to paint a lot. If you are an artist and you make the perfect blue paint, why is it important to figure out what colors you mixed for that paint? Leo? Okay. So you can make it again, but let's say you wanted to test a small color, because if you need to paint like a whole room, would you want to just try, guess and check different paint colors in large quantities? No, because you would waste a lot. So you would test in small quantities and then duplicate that. So let's just talk about perfect blue paint. Let's say we mix a dark blue and white. How could I make sure I duplicate it on a bigger scale?
Just put more white and more blue.
But how would I know exactly how much white and how much blue? What do you mean by measure?
Like every 1 cup of white, 2 cups of.
Okay, so Dom said for every 1 cup of one, I need 2 cups of the other.
Or like every bucket. Well,
Or every gallon of one, I need a gallon of the other, okay? But that's ratios. To keep those consistent, you're creating really an equivalent batch, just in a bigger quantity. Okay, so that's what this one's about. Blue paint and art paste. Alina mixed 2 cups of white paint with 6 tablespoons of blue paint. Here is a diagram that represents the situation. Discuss the statements that follow and circle all those that correctly describe the situation. Make sure that both you and your partner agree with each circled answer. I'm your partner. Okay, so first I suggest doing a little bit of work when you have these, because they'll give us different answers. Remember, these ratio answers can be written lots of different ways, and you're deciding which of these is correct, which of them is wrong. So let's start with what we know. What is our ratio of white paint to blue paint? White paint to blue paint. And I'm going to write it right here. I'm going to write white to blue. I want you to do the same. White to blue. Tatum? Okay, and I'm going to put labels. Why do you think I'm going to put labels on this one? They're both paint, but are they the same label? No, you're putting 2 cups of white. So I'm going to put 2C of white to 6. I'll just put a T. It's tablespoons, but I'll just put a T just so we have something there of blue paint. If that was your final answer, if it asked what is the ratio of white to blue paint, is that a good final answer? Why not, Emmy? Yeah, it could be simplified to what? 1 to 3. So I'm going to put 1 cup to 3 tablespoons. And again, that's not the proper abbreviation for tablespoons. Just putting something there to keep us on track. TBSP. Okay, so now let's read our choices, because that's about all we can do with it, but we could say that a lot of different ways. So A says the ratio of white to blue. White to blue is 2 to 6. So let's check ours. We did white to blue, 2 to 6. Do we agree with that one? Yeah. Yes. So let's circle it. And sorry, they had cups of white, tablespoons of blue. We needed to check. Well, it's one way we could write it. We're not saying it's the best way to write it, but it is a true statement. Okay, so let's circle A. B, for every cup of white, so I'm going to underline that, cup of white, there are 2 tablespoons of blue. So if we look, for every 1 cup of white, we need 3 tablespoons of blue. So is that one correct? No. Mark out the 2. You might need to do it like this and put a 3. To make that one true, that would have to be a 3. You guys have room to do it in your book. I don't. So you can just mark it out and put it there. C, there is 1 cup of white for every 3 tablespoons of blue. 1 cup of white for every 3 tablespoons of blue. Do we agree with that one? Yep. C is good. D, there are 3 tablespoons of blue. So 3 tablespoons of blue for every cup of white. So 3 blue. And if we look here, 3 blue for every 1 white. Do we agree with that? Yeah. Yeah, what did they do? All they did was flip it, but they also flipped the words. Is that okay? Yes, as long as they flipped the words and the words match the numbers, it is good. E, for each tablespoon of blue, there are 3 cups of white. For each tablespoon of blue, 1. Did we get our blue down to 1? Nope, we haven't learned how to do that yet. We're getting there. We can, it's just less than 1.
Oh, it'd be a fraction.
It'd be a fraction. Let's do it real quick. We need this to get to 1. Let's go ahead and come back up here. It's not hard, we just haven't done it. So 1 tablespoon. How do I get from 3 to 1? Divide by 3. What's 1 divided by 3? Don't overthink it.
1/3.
1/3. So 1/3 cup. So is E correct? Nope. What do we have to change the 3 to?
3, and then it's
1/3. Ethan, read me F because I can't scroll down.
For every 6 tablespoons of blue paint, there are 2 cups of white paint.
So 4 tablespoons, 2 cups. Nope, because if it's 2 cups, what would the tablespoons have to be?
for every 6.
It would have to be 6. So fix it to make it say 6.
6 is on here.
Oh, wait, he didn't say 4?
He said for every 6 tablespoons of blue paint, there are 2 cups of white paint.
Okay, so F is correct.
Yeah, because for every 6, they just flipped it.
I thought you said 4.
G, the ratio of tablespoons of blue paint to cups of white paint is 6 to 2. It says blue to white.
Yeah.
Blue to white, 6 to 2 is also yes. Turn the page. Okay, so don't turn the page. Still on page 17, I want you guys to try number 2. Jada mixed 8 cups of flour with 2 pints of water for an art project. Try and draw that in a diagram. And remember, you can just use basic shapes and write at least 2 sentences describing the ratio. Page 17. Sorry, I told you to flip. I didn't realize you're number 2. I thought it was on the next page. Okay, so take a minute, try and draw that diagram. And again, all of our diagrams won't necessarily look the same.
What's a pinch of water?
Where do you see pints? Pint. Okay, let's go over it. So again, on your diagrams, you can really use any picture, but label your picture so you can keep it clear. I saw a lot of you put like an F for flour, and what's the other one? Water. Okay, so I'm going to put an F for flour, a W for water. Okay, what do we know about flour, Jake?
There's 8 cups of flour.
Okay, 8 cups. You could use any shape. Okay, I'm going to use squares. And 2 pints of water. Now, thinking ahead, what do we always have to do with ratios? Just like fractions. Simplify them. If I'm working with 8 and 2, we can divide them both by 2. So usually when you set up the diagrams, I'm just going to use like Hallie used big circles for the water, which is fine. Usually when you're setting up the diagrams, you're kind of pre-grouping them together, kind of anticipating what's coming. If you didn't do that in the beginning, that's fine. But then if you can group them in 2 perfect groups or 3 perfect groups or 4 perfect groups, each group is really your simplified answer, your simplified ratio. But again, there's other ways to get that. So there's a diagram. You don't have to have the boxes around it. I was just showing you there's 2 groups of the same thing. Write at least 2 sentences describing the ratio of flour and water. So I'm going to write out a couple of ratios here. I know it's 8/2, and I'm just doing flour to water because that's how I have it set up. That would reduce to 4/1. Okay? Who has a ratio, a sentence they think is correct? Elise, give me one of yours.
8 cups, 2 pints.
Okay, so you would have to say, because it just said write a ratio, you would have to say the ratio of blank to blank is blank to blank.
Wait, is that a sentence?
Is what a sentence?
That
Diagram?
The diagram is not a sentence, no.
no, like the word, the
Numbers are not a sentence, but you can say the ratio of flour to water is 4 cups of flour to 1 pint of water. Leo, what do you have?
Ratio of water to flour is 2 pints to 8 cups.
Okay, the ratio of water to flour is 2 pints to 8 cups. That works. Emmy?
For every 4 cups of flour, there is
For every 4 cups of flour, there is 1 pint of water. Correct. Owen?
For every 1 pint of water, there is 4 cups of flour.
Yeah, for every 1 pint of water, there are 4 cups of flour. Okay? So really, this is the same thing as yesterday. The only thing they added in is the diagrams. And the only reason you need to know diagrams is you don't necessarily have to be able to draw one, but when they give you a diagram, you have to be able to understand what it's giving you.
Can they just give what are the ratios for, and then just give that?
Yeah, but they would give more information, so each picture would represent something. Okay, so your homework tonight is very similar to last night's homework. Flip over to page 20. You're going to do practice problems 1 through 5, which is page 20, 21, and there's one on 22. The hardest problem will probably be number 4, because you have to decompose. You'll probably have to decompose that shape. You're doing 1 through 5, so it's all of the practice problems. It's 1 through 5 practice problems, so it's page 20, 21, 22. Number 1's like the first one we did together.
So some of these are just like what we've already learned.
Yeah, so number 3, 4, and 5 is all old stuff. Number 5 is like the number talk that we did at the beginning. Okay?
It's just decomposing and recomposing.
Yeah, number 4 is like you'll have to decompose